Hello everyone. Okay, so today we are going to be looking at binomial expansion. We're going to be looking at the binomial theorem and using the binomial theorem to expand binomial expressions. We are also going to be looking at the general term formula and using that to find specific terms within a binomial expansion. And then finally, we're going to be looking at some exam paper questions in which we are asked to find terms independent of x. So, before we can even talk about the binomial theorem, we have to talk about Pascal's triangle. Now, Pascal was a mathematician, and that's all I remember. Anyway, he left us this triangle, so let's kind of discuss it for a bit. What's great about this triangle is, so we're going to look at all of these binomials. So, if you recall, a binomial, bi means two, so it's a Greek or Latin or whatever. It's a suffix for prefix for two. So binomial. So it's a two-term polynomial. So I have x plus y, that's my polynomial. So x plus y to the power of 0, well, that'll give me 1. Okay. X plus y to the power of 1, that gives me 1x plus 1y. Okay, that's like fair enough. X plus 2, x plus y all to be squared, that's 1x. Sorry, let me just... Can't really see it now, but... Right. That gives me... 1x squared plus 2xy plus 1y squared. Okay, now x plus y to the power of 3 is equal to 1x cubed, 3x squared y, 3xy squared. Y cubed. Okay, it's getting a bit complicated now. But do we notice the pattern here? Well, if we notice the pattern here, is if we always end in 1, right? Our binomial expansion always ends in 1. And if we look here, the two terms add to get the term directly below it. So if you look here, right, the x plus y squared, well, they have to end in 1. 1 plus 1 is 2. If you look here, end in 1. 1x cubed, 1y cubed. Then 1 plus 2 is 3. 2 plus 1 is 3. Same thing here, ends in 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then ends in the 1y cubed. Of 4 to the power of 4. So the coefficients follow that pattern there. But then also, if you look at the x's are going down in power, while the first term is going down in power, while the second term is going up in power. So if you look at the x's here, I have x cubed, then it's x squared, then it's x. Then I have nothing, but that's actually x to the power of 0. Right, because x to the power of 0, anything to the power of 0 is equal to 1. So anything multiplied by 1 is itself. So x to the power of 4, x to the power of 3, x to the power of 2, x, 0. Same here, 5, 4, 3, 2, 1, 0. Same thing with the powers of y. So 0, 1, 2, 3, 4, 5. So while the first term goes down, the second term goes up, and then the coefficients can be determined by adding them. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and it has to end in 1. Right, so you could remember this whole Pascal triangle thingy, but literally effort of doing that. So that's why we have this handy dandy little binomial expansion formula. So binomial expansion usually refers to questions in the form a plus b to the power of n. To solve these questions, we use binomial theorem. This is in page 20 of your log tables. So the key formula, it's here. This is what appears in your log table. X plus y to the power of n. That is equal to this n thing. This thing. What's this thing? What's that thing? Well, this is a new notation. This is called choosing, right? So we won't delve too much into it because it's more of a probability kind of concept. But if I say have here 3, 2, something like this, this literally says 3, choose 2. And what that literally means is how many groups of 2 could I make from a set of 3? So say, for example, I have John, Harry, and Derek. I could have a group of John and Harry. I could have a group of Harry and Derek. And I could have a group of John and Derek. Right? And that's it. So 3 choose 2 should equal 3. But, you know, you're not going to be listing out names and doing this in the exam. So we're going to use a calculator here. So if I open up my calculator here, oopsie poopsie. Right, there you go. Got it eventually. Right, if I open up my calculator here, how I want to write combinations is I want to do 3. So I want to do 3, choose 2. So I'm going to do 3, choose. Now, in maths, you mightn't be able to see it right here, but above the division symbol, there's a little symbol called NCR. So the C means choose. So I'm going to click Shift and then the division symbol, and I have this C here. Now, if you have one of the newer calculators, I think you have to go to your formula table thing, and go to the probability, then to choosing, but hopefully you don't have that calculator, so it'll be fine. Right, so 3, choose, then 2 equals 3. Bada boom, bada bing. So we could do this with even bigger numbers. So let's just say, how many groups of 2 could I make from a set of 5? Right, so 10 choose 2 is 45. So I can have 45 different groups of 2 from a set of 10. So that's what choosing means. And then something to note about choosing. Is, so n choose or, so something chosen the number is going to be equal to n choose n minus or. Again, why am I telling you all these variables? Let me show you an example. So 9 choose 3, for example, would be equal to, in this case, n is 9 or is 3. That will be equal to 9 choose 9 minus 3. So that's going to be 9 choose 3 should be equal to 9 choose 6. So they're kind of following a kind of symmetrical kind of property, right? And that symmetrical property derives from Pascal's triangle. So 9 choose 3 will equal 9 choose 6. Like 12 choose 5 will equal 12 choose 7. You know? 45 choose 14 will be equal to 45 choose 31. Right? So see how the bottom numbers all add up. So 3 plus 6 is 9, 5 plus 7 is 12, 14 plus 31 is 45. So that's choosing. So you just have to remember is how many groups of blank can I make from a set of blank, and how you do that in your calculator is Shift and then you click your division symbol. So there's my formula here. So the coefficients are all this new notation here. So I start off with x to the power of n. So the n is the number I put in the power I'm putting my bracket to. I start off with n choose 0. Right, so my coefficient for x to the power of n will be n choose 0. And then it'll be n choose 1 to the power of n minus 1. So the power of x is going down by 1, and then the power of y is going up by 1. So see here, it's gone down by 2. Y squared, this is y to the power of 2. So this is going to happen until you kind of run out, essentially. Now, this here is in your log tables as well. It's hidden away, so it's not specifically listed, but this is your general term formula. So this general term formula helps us find specific terms within a binomial expansion, but I'll show you how to do that in a moment. So to note, n is the power given in the question. So again, this, and then here's the symmetrical property. So n choose or equals n choose n minus or. 6 choose 4 is equal to 6 choose 2. Or starts at 0. So that's really important here. So in my formula, or starts at 0. So I always start at 0 here. So the first term is or equal 0. So the first term of my binomial expansion always happens when or is 0. And the second term is or is equal to 1, etc., etc., etc. So or is always 1 less. It's always 1 less than the term we're trying to find. So again, here is our general term formula. So t or plus 1. Again, this subscript just means which iteration we're looking for. So t4, for example, would be the 4th term. You know, t6 will be the 6th term. t10 will be the 10th term, etc., 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 etc. So remember, the value of or is always 1 less than the term you're looking for. That's really, really, really important. So let's have a look at this example here, because I actually wasn't bothered to write it out, so you're just going to have to look at it with me. I want to use the binomial theorem to expand 2x minus 3y all to the power of 4. So what I do is, I use my formula up here. So n is going to equal to 4. Right? So x in the formula is going to equal 2x. Y is going to equal minus 3y. And then m is equal to 4. And then what we do is we just sub it into my formula here. So my first term is 4 choose 0 times 2x to the power of 4 times minus 3y to the power of 0. That gives me 16x to the power of 4. And then I keep doing this. So 4 choose 1 times 2x to the power of 3 times minus 3 to the power of 1. When I multiply all that out, 4 choose 1 is 4. And then 4 times, this is going to be 8x cubed. So 4 times 8 times minus 3, it's going to give me minus 72. X cubed y. And then 4 choose 2. Again, look here, 2x to the power squared. So the x's are going, the power of the first term is going down. 4, 3, 2, 1, 0. And then if you look here, the power of the second term is going up. 0, 1, 2, 3, 4. And then when you put this in your calculator, now you wouldn't put this in your calculator all on its own like this. So what you usually put in is you usually kind of expand it out. So 4 choose 0, you put that stuff in your calculator. 2x to the power of 4. Right, now you can't put x's in your calculator, so you just have to kind of do it out in your head. Like what 2 to the power of 4 is 16x4, and then that's going to be 1, and then you're going to multiply all of that out. Right, so we'll do an example now in a minute, but in this case here, find the fourth term of 2x plus 3 to the power of 6. So we want to find the fourth term. So first of all, n is equal to 6. Or, in this case, remember, or is always going to be one less than the term we're looking for. So I'm looking for the fourth term, therefore, or is going to equal 3. And then x is going to equal 2x, y is going to equal 3. So let's sub it in. So I have t, 3 plus 1 is equal to 6, choose 3, x to the power of, well, x in this case is 2x to the power of n minus or, so it'll be 6 minus 3, times y to the power of or, so it'll be y to the power of 3. 6 choose 3 gives me, I don't know what it gives me. I don't have a calculator. Oh my goodness. Hold on. To quote Kendrick Lamar, hold up, wait a minute. Right, 6, choose 3. That is going to give me 20. This is going to be 2x to the power of 3, and that's going to be y. Oh, y in this case is 3. I made it boo-boo again. Y is equal to 3. Y is equal to 3, right? So I have 20 times 2x cubed is going to be 8x times 3 to the power of 3. 20 times 8x cubed times 27. So 20 times 27 times 8. So I'm going to have 4,320x cubed. That is the fourth term of this expression. So let's look at some more examples here before we move on to the harder stuff. So I have two examples here. Use the binomial theorem to expand 3x plus 2y to the power of 3. So again, 3x plus 2y to the power of 3. So we start off, I have 3, choose 0. 3x to the power of 3 times 2y to the power of 0 plus 3, choose 1 times 3x to the power of 2 times 2y to the power of 1 plus 3, choose 2 times 3x to the power of 1 times 2y to the power of 2 plus 3, choose 3 times 3x to the power of 0 times 2y to the power of 3. So that is going to be equal to 3 choose 0 is this going to be 1. 1 times 3x cubed, so it'll be 1 times 27x cubed times 1, because 2y to the power of 0 all goes to 1. So my first term is going to be 27x cubed. My second term is going to be 3 choose 1 is 3. So I have 3 times 9x squared times 2y. My third term is going to be 3 choose 2. 3 choose 2 is 3. 3 times 3x times 2y squared. 2y squared, that's going to give me 4y squared. And then I'm going to add on 3 choose 3, which is 1, times 1 times 2y cubed is going to be 8y cubed. So my final answer here is going to be 27x cubed plus 3 times 9 times 2 is 54. 54x squared y plus 3 times 3x times 4y squared. So 3 times 3 times 4. So my coefficient is 36. 36xy squared plus 1 times 1 times 8y cubed. So my answer is going to be 8y cubed. And that's my final answer there, expanding it all out. Right, let's look at the next one. Oops, sorry. Find the middle term of x plus 1 over y to the power of 9. We want to find the middle term. So you have to think, what's the middle term? Well, it's the middle bang in the center. So if you look, you have the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term. If I notice here, the fifth term is bang in the middle because I have 4 this way. Oops. I have 4 to the left and I have 4 to the right. So the fifth term is middle. Fifth term is the middle term. So in that case, or is going to be, so remember, or is always 1 less. So or is going to equal 4. So let's sub in my formula. So x plus, now this 1 over y, don't really like it. So I'm going to rewrite this as y to the power of minus 1 because that is indices. If you don't remember the indice rules, you do have to go back over them. So power of 9, that I'm looking for the middle term. So I am looking for the middle term. Which is the fifth term. So sub into my general formula, t or plus 1 is equal to n choose or times x to the power of n minus or times y to the power of or. That is going to be t choose 5 is equal to 9 choose 4 times x to the power of, in this case x is just x to the power of 9 minus 4, which is 5, times y to the power of minus 1 to the power of or, in this case or is 4. So I have the fifth term and the middle term is equal to 9 choose 4, which is 9 shift and divide 4 is equal to 126. X to the power of 5, y to the power of minus 4. And that's my final answer there. Right, I hope I was correct for all of these. And we have one more section left in this video. And this section is how it will most likely come up in an exam. Funny enough, this hasn't really come up as a question really in an exam since like 2013. But, you know, due to the unpredicted nature of the state examinations, you can never be too sure. So that's why we're going to look at here terms independent of x, right? So let me just rub out this so I can do it myself. Right. So, note, if we are ever asked to find a term that is independent of x or any other variable, that means we are looking for a term that doesn't have x in it, i.e. the power of x is 0. So what do we mean? We don't know what term we're looking for, so my unknown in this expression is going to be or. So what I have here is I want to find a term independent of x. Well, I don't know what or is, so I'm just going to leave or in my equation. 5 choose or 5 because my bracket is the power of 5. X to the power of n minus or. So x in this case is 2x squared. Putting that all to the power of 5 minus or. Times y to the power of or, which is minus 3 to the power of or. Now I have here 5 choose or times, now power to a power I multiply. So actually not, first off I have to do this, 5 minus or. I have to split this power up, and then power to a power I multiply. 2 times 5 is 10. 2 times minus or is minus 2 or. Again, if this looks absolutely alien to you, you need to go over your indice rules, because I've used the rule here, ab to the power of like x is equal to a to the power of x times b to the power of x. I used that indice rule there. I've also used the indice rule, a to the power of x to the power of y is equal a to the power of x, y. So if I have a power to a power, I multiply. If I have a product to a power, I can product to a power, I have a product to a power, I can split the products and put the power on each term. So, and then I have minus 3y to the power of or. Now, I'm looking for the term independent of x. So therefore, all of this has to equal 0. So the power of x has to equal 0 in order for me to have no x's in it. So once I do that, I have 10 minus 2 or is equal to 0. Or is going to equal to, when you do out this equation, or is going to equal to 5. So therefore, my independent term is going to be in my sixth expression. Not my sixth expression, my sixth term. So if I sub that in, so T6 is going to be equal to 5 choose 5. 2 times 2x squared to the power of 5 choose 5, which is 0. And then minus 3y to the power of 5. I have 5 choose 5 is 1. All of this to the power of 0 is 1. Then minus 3y to the power of 5. Well, minus 3 to the power of 5 is minus 243. Yeah, that's correct. Okay. And then y to the power of 5. So my answer is minus 243y to the power of 5. That is the term independent of x. Right, let's look at some exam style questions. So investigate the binomial expansion. 5x to the power of 5 minus 1 over 5x cubed to the power of 15. So first of all, I don't like this. I want to rewrite this. This rewrites to minus 5x cubed all to the power of minus 1. And then, yeah, or which is just minus 5x cubed all to the power of minus 1. So I'm going to rewrite this out now. So I have 5x to the power of 5 plus minus 5x cubed all to the power of minus 1 to the power of 15. So my general term, t or plus 1, that's going to be 10 choose or, so I'm using my formula, 10 choose or times 5x to the power of 5 to the power of 10 minus or. Not 10, it's 15. I don't know why I said 10. Next one's 10. 15. 15 minus or times minus 5x cubed to the power of minus 1 to the power of or. Now, I'm going to split off these 5's here. So 15 choose or is equal to 5 choose 15 minus or. So that's the rules of indices. If I have a product to a power, I can put the power on each product. X to the power of, now I'm going to have x to the power of 5 to the power of 5 minus or. So power to a power. It's power to a power, I multiply. So 5 times 15 is 75. 5 times minus or is minus 5 or. Minus 5 to the power of minus 1 to the power of or. And x to the power of 3 to the power of minus 1 to the power of or. So I'm going to have 15 choose or. Now, I'm going to bring all these over here. So I have 5, 15 minus or times minus 5 to the power of minus or times, now power to a power, I multiply. So I have a power to a power to a power. So it's going to be 3 times minus 1 times or, which is going to be equal to minus 3 or. So I have here now x is equal to the power of 75 minus 5 or times x to the power of minus 3 or. And now to finish off my general term here, a power to a, when I'm multiplying two numbers in the same base, I add their powers. So I'm going to look here. So I have t or plus 1. Let me just double check something here. Yep. So t or plus 1 is going to be equal to 15 choose or times 5 choose 15 minus or minus 5 choose or minus or. And then add these pairs together. So 75 minus 5 or minus 3 or is going to give me x to the power of 75 minus 8 or. And that is my general term. Let's look at part 2. Part 2 just asked us here, compute the coefficient of x to the power of 11. So if the coefficient of x is 11, the power of x in my general term is equal to 11. So therefore 75 minus 8 or is equal to 11. Do some maths, or is going to be equal to 8. And then once or is equal to 8, I can sub it into my formula. So I have 15 choose 8 times 5 to the power of 15 minus 8, which is 7, times minus 5 to the power of minus 8 times x to the power of 11. If I put the first three bits in my calculator, I have 15 choose 8 times 5 to the power of 7 times minus 5 to the power of minus 8. And you put all of that in your calculator, you're going to get 1287 x to the power of 11. Right, so you get that there as your final answer. Okay, let's look at the next action of the last final part here is prove that there is no term independent of x in the expression. So if a term was independent of x in the expression, here 75 minus 8 or, so I'm going to make that 5 a bit more pronounced, should be equal to 0. So 75 minus 8 or equals 0. You do some math, you're going to get some or is equal to 75 over 8. This cannot work. Right? This can't work because or is a fraction. Right? And or needs to be a whole number a whole positive number in order to work with my binomial theorem. So therefore this can work because or is a fraction. So let's look at this another exam style question. Again, it's the same process here. 2x cubed minus 1 over 3x squared. So let's look at this one here. Minus 1 over 3x squared. I could rewrite that as minus 3x squared all to the power of minus 1, which will break down to minus 3 to the power of minus 1, x to the power of minus 2. Anyway, let's just do it out here as normal. So I have minus 3x squared to the power of minus 1 to the power of or. 10 choose or is equal to 2 to the power of 10 minus or times x cubed. So this is x cubed. So now if you can see it, x cubed 3 times 10 is 30. 3 times minus or minus 3 or. Then here minus 3 to the power of minus 1 to the power of or. This is going to be minus 3 to the power of minus or. And then x squared to the power of minus 1 to the power of or is going to be x to the power of minus 2 or. So gather my x terms like we said. So 10 choose or. is equal to 2 to the power of 10 minus or, minus 3 to the power of or. And if I gather my x terms here, right? So remember, if I multiply two things, same base, add the powers. 30 minus 3 or minus 2 or, that is going to be 30. Oh, nope. That's going to be x to the power of 30 minus 5 or, because minus 3 plus minus 2 or is minus 5 or, and that is my general term. Next part, same question as before. Calculate the coefficient of x is equal to x to the power of 10. So therefore, this has to equal 10. 30 minus 5 or has to equal 10. So 30 minus 5 or equals 10. Minus 5 or is equal to minus 20. Or is equal to 4. So I'm going to be looking at the fourth term of this expression. So when you sub in or is equal to 4, you get 10 choose 4 times 2 to the power of 6 times minus 3, oh that's a minus or there, to the power of minus 4. X to the power of 10. Again, put the first three things in your calculator. So 10 choose 4 multiplied by 2 to the power of 6 multiplied by minus 3 to the power of minus 4. And then you get a fraction. A lovely doubly fraction. And you get 4480 all over 27x to the power of 10. That's my answer there. Hope it's right. I'm not arsed to check. I think it is. Right, then finally, last term here. Find the term independent of x. So if something is independent of x, the power is equal of x is equal to 0. So 30 minus 5 or is my power of x. That's going to equal 0. I have minus 5 or, then is equal to minus 30. Or is going to equal to 6. So find the term independent of x. It's going to be the seventh term. And if I sub that in, to my calculator, I'm going to get 1120 all over 243. And that is my final answer. That is the seventh term. And I have no x's in it because it's independent of x. Finally, let's look at this last exam question. This is from 2001. None of these were born yet. But in the binomial expansion 1 plus k x to the power of 6, the coefficient of x to the power of 4 is 240. Find two possible real values of k. So the coefficient of x to the power of 4 was 240. So I have n choose or times 1 to the power of n minus or times k x to the power of or. Now I want x to have a power of 4, and the only way it will have a power of 4 is if or is equal to 4, because the only thing that has x in it is this term. So or is going to equal 4. So I have 6 choose 4, so say n is equal to 6. I should really put that in there. 6. So 6 choose 4 times 1 6 minus or times k to the power of or x to the power sorry sorry bing 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 sorry bing 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 6 minus or this is going to be 6 minus or, so 6 minus 4 is 2, and I have k to the power of or, which is going to be 4, and then I have x to the power of 4 here. So I know all of this has to equal 240. So 6 to the power of 4 is 15. So I know 15k to the power of 4 is going to be equal to 240. 240 divided by 15 is equal to 16. So I have k to the power of 4 is equal to 16. So the fourth root of 16 is going to be equal to plus or minus 2. Right? So because it asks here for two possible real values of k. And you can check it out for yourself. 2 to the power of 4 is equal to 16. And then 2 minus 2 to the power of 4 is also equal to 16. So you sometimes have to remember, if they ask for two values and you're dealing with square roots, you have to remember if you're including the positive and negative answer. Right, and that concludes this video. It's a bit of a doozy, but I did every question in this booklet, and I hope it helped, and I'll catch you guys later. Bye. 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 Bye.